Hi everybody, we are going to see new features included in the new version of Minitab 17. These two features that are shown in this screen are featured, as I have already mentioned, included in Minitab 17, and I'm going to explain them using some screenshots and some examples. The first one, that is one tool for parameter estimation. You can find it following this path that is behind the Start menu of the toolbar. Then scroll down, and behind Power and Sample Size you can find Sample Size for Estimation tool. This window pops up once you click on Sample Size for Estimation, and scrolling down you can find several examples where you can estimate different parameters: the mean, standard deviation and variance from normal distribution, proportion from binomial distribution, and the rate of the mean rate from Poisson distribution. Then you can work out the margins of error of an estimation if you already have a sample, or the other way around, if you know the margins of error that are appropriate for your process or for your customer, then you can find out the appropriate sample size. For process capability using parameter estimation tool. Let's imagine we are measuring process capability using binomial. So our parameter would be the proportion P. We have followed practical rules to estimate our parameter that will be used as a baseline. So 1000 units would be enough following this rule. So it turns out to be a process with 10 out of 1000 no-OK parts. So our proportion would be 0.01, 1%. TPMO, Z value, and PPK can also be calculated. Let's see how work out an estimation using Minitab features, new features. And this tool would give us a new point of view. So this proportion that was 0.01 due to the sample size would generate a margin of error of 0.01 plus this number and 0.01 minus this number. So our confidence interval with a 95% of confidence level would be this one. So imagine our customer expectation or our process requirement is, or our target is 98.5% of first time through, 98.5% of OK parts. So our proportion, our target proportion would be 1.5%. So this means that we would have a risk of not meeting customer expectations. So what we have to do is to get more samples in order to be sure that our margin would prevent us from not meeting customer or process target. So a sample using this margin of error, then this margin is calculated from 0.01 0.01, and our target that was, as you remember, 1.5%. So the margin that prevent us from not meeting customer expectations would be this one, 0.004. So this gives us a sample size of 3,322 parts. So if we take these units from the process, imagine we have a third estimation of 0.009, 0.9% with this sample size. So a third iteration of proportion estimation would be this one. So in this case, we would be quite sure of meeting customers' expectations, as the upper value of the confidence interval would be below 1.5%. That was our target. So now we are 95% sure that we meet the target, since this is our confidence, our new confidence interval. So the same will apply to any distribution. The message is that process capability is also an estimation due to sampling. Therefore, we need to find out a suitable N for our process versus target comparison. Alpha and beta means. Alpha is, as we have already mentioned, alpha is our type 1 error. So is the proportion of no okay part when the expert has said okay part. This is the proportion of no okay part measured by the machine as no okay, and so they are evaluated as no okay when these were no okay parts. And beta is the other type of error, that are the parts assessed or evaluated as okay from the total amount of no okay. Then these proportionals are 3 out of 100 units, 3 assessed or evaluated as no okay from the total number of 100, that is 3%. So the rest of 97 units were agreed with the expert. The machine agreed with the expert. So 3 out of 100 were assessed as no okay, and 97 were assessed as okay parts or units. Beta is 5.2%, and they were for okay parts where indeed they were no okay. So they are 4 out of 77. The rest of 73 units were also assessed no okay by the machine. It seems to be okay for most characteristics, as the typical criteria for alpha is equal or less than 5% and beta 10%. So we would accept our measurement system following these criteria. Now let's see what happens when sample size and confidence interval is taken into account. As they are proportions, using sample size for estimation tool from Minitab 17, then this gives us this confidence interval for alpha and this confidence interval for beta. So as we can see, these numbers are above 5% in the case of alpha, and 10% in the case of beta. So the conclusion is we are not sure. We have a risk of not meeting customer expectations. So a new sample size would be 561 samples for alpha and 154 for beta. The other tool is hypothesis testing for Poisson. Then, when we use attribute variables that are okay, no okay, go, no go, or this kind of features, of this kind of characteristics, then we use binomial, multinomial, or Poisson distribution. So when we have a metric showing our level of defects as defect per thousand or defect per unit, this means we are using Poisson distribution. Proportion, FTT, or repairs per thousands would be that of binomial distribution metrics. So we can find this tool following this path in the menu. Basic statistics and 1 sample Poisson rate and 2 sample Poisson rate. Also, previous to or before doing this, we have to be sure that we are using a correct sample size for a certain beta and alpha risks. Why we should use Poisson distribution instead of binomial distribution? Well, for processes with a high level of defects per unit, or simply or just when we can have more than 1 defect per unit. Then in this case, in this example, imagine we have a process that we have improved from 3 to 2 defects per unit. So we can say that we have 33% less issues than before. That is a big improvement. If we have measured this process using FTT instead of defects per unit, then our calculation would show us this level of improvement, only 9% improvement. Is it true? Don't you think cost is better? And therefore level of issues avoided are more related to 33% than 9%? This is an example of why using defects per unit instead of proportional FTT first time through. This is all for today, and I'm looking forward to the next feature, and I hope you are going to use these new features of Minitab with your Six Sigma projects. Bye bye, see you next time.